Welcome back to Electricity with Mr. B. In this session we're going to explore continuity and resistance. In the last session we explored how to use the digital multimeter in order to measure voltage and amps, and we're going to use that again today to demonstrate use of resistors. So let's have a little look at a simple circuit that I've made. So we start with the battery coming out of one terminal, the positive terminal. We've got the red wire going around to the green wire, which then joins the LED through the yellow wire that's attached to it. White wire comes out the LED, connects to the black wire, which goes into the negative terminal of the battery. A straightforward circuit. Now you might be wondering, why have I put so many wires into it? Why red, why green, why black one? Well, the colours aren't as important, but the reason this extra green wire is here is so that I can connect extra things to it. Let me show you what I mean. Now, I want to change the brightness of my LED, so I'm going to use one of these. It's known as a resistor. And what that does is it's going to limit the amps that are able to travel around the circuit, which should mean that it will change the brightness of the LED. So let's wire that into the circuit. So if I disconnect these two, see the LED goes out, and I'm going to add the resistor into the circuit. You can see it lights up again. Now if I just flick between the two, fully lit, through the resistor, you should be able to see a subtle change between the two. Now in fairness, the difference between those two brightnesses wasn't that much, so I've got myself a different resistor which should demonstrate it a bit better. So normal circuit, running through the resistor, normal, resistor, quite a bit of difference, so it's much dimmer. Let's find out exactly how much dimmer, and that's where the digital multimeter comes in. So remove the resistor for now, I'll put it back on in a minute, and I've interrupted the circuit with the probes from the digital multimeter. So if we follow that circuit round again, go from the battery, red wire into the red probe, which goes into the digital multimeter. It's not on at the moment, which is why the LED is not on, and comes out of the black probe goes around, joins the green wire, connects to the yellow, connects to the LED. So if I now set that to, let's see, 200 milliamps, and we can see it's completed the circuit, and we've got about 0.3, 0.2 milliamps. So not very much at all for an LED, but that's not the point. We want to see how different it is when we introduce the resistor. So we're going to take that off, and we're going to connect the resistor, and we can see it's lit up. In actual fact, at that scale it can't quite pick up the number of milliamps. That's how low it's gone. See if we can change the setting to make that appear. That's a bit better. We've got it set to 2 milliamps. So let's try it without the resistor wired in. So we just touch the connector bypassing it, lights up fully, and we get it's much more accurate this way. We get 0.181 or thereabouts. Oh, it's jumped around a little bit, 0.152, 0.16. The reason it's jumping around is just the connection of the wires. They're not terribly good, but we get a rough reading. And let's try it with the resistor. Again, lit up, not very much, and this time it's gone way down, 0.020. So you can see there's the amps has gone down quite considerably because of that resistor. So this is really handy if you want to change in your circuits how bright your LEDs are, and can also affect the behaviour of circuits as well. You find loads of resistors within circuits. Continuity is simply seeing whether two wires join up, or whether there is a link between one place and another. which is quite handy. So for example, I've got a wire here that I've been using lots. It's quite old, and I'm not convinced that it works. I could just wire it up to a circuit, but I run the risk of something going wrong, and I can't be certain, or maybe the battery's gone, maybe the bulb has gone. So I want to test the wire. Very simple way to do that. I turn my DMM to the red setting. So at the moment there's a 1 because my 2 probes aren't connected to anything, but if I touch them together, it completes the circuit, and I get a beep saying that there is continuity because they're touching together. So that means anything I put between these, if it completes the circuit, will set off the buzzer in a completely safe way that's not going to damage any of my equipment. So I'm going to test my 2 probes on this wire. So we've got one connected to one end and one to the other. Unlike voltage and amps, doesn't matter which way around it is, it will work both ways. So touch it together, and nothing is happening at all, which means this wire is indeed broken. There is somewhere in the circuit where it is not allowing electricity to travel through. Just check. If I touch it on there, see at this end, no problem at all. This end, not working. Let's have a closer look at that. It looks to me as if we have a bit of a rusty connection at this end, and let's see what's going on at the other end. Peel back this rubber. Right, peel back the rubber at this end, and straight away we found the problem. This is not actually attached properly at all to the wire. The crocodile clip and the wire are just barely touching each other, so there's no continuity, which is why the circuit wouldn't work. So we're going to throw that away. And let's just test my alternative wire. So we attach it to the probes. 1. There we go. Straight away we have continuity, which means that wire will work perfectly. The continuity feature is also quite handy if you have a lot of wires and you're not quite sure which one is supposed to connect to which. For example, we've got a lot going on in here, and we don't want to suddenly start connecting wires here and there, where it's all going to go wrong. So we simply use the DMM to double check, is this wire at the other end of this wire? Yes it is, so we know that one connects to that one. Very handy for electricians when they're figuring out what goes where. Well, hopefully you've learned a little bit more about digital multimeters and resistors in this session, and I'll see you next time. Bye.